We are recording. Okay, hello, hello. So, okay, y'all. So, just a reminder for our in-person class, y'all. I'm not bringing in like paper copies of the notes anymore, but I do have them posted here. So, you can always click on the link, and if you want printed copies, the CLE is right next door, just right next to us on this side of Building A, and you can always go in there and print it out. That let you print out whatever you need. So, all the notes are right there. So, just a heads up. Y'all, one more thing. We do have a written class assignment. Again, the class assignment is right here. So again, you have a couple options. If you want a paper copy, just go next door and print out a paper copy. It's only 4 questions, only one sheet. It's not a lot of stuff here, okay? So y'all, when you're gonna, class assignment 1 is due a week from today, right? It's due on the 21st. So you have a couple options. If you want to turn it in earlier, you're more than welcome to turn it in earlier, okay? So if you want to turn it on Monday, that's fine with me too. So you got a couple options. If you want to turn it in class, turn it in either on Monday or Wednesday. It's not actually due until the end of the day on Wednesday. Okay, it's not actually due till the end of the day. It didn't mean you got to wait till the end of the day to turn it in, but that's when it's due. So if you want to bring it in to me, that's fine. If you want to turn it in online, what you'll do is you'll work everything out, right? You can take a picture of it or whatever. If you're doing it on your iPad, save the file, and then send it to me via Blackboard messages. Okay. So you'll come up here to messages, and you'll send a message to me, right? And you'll attach it right there. Okay. So you got a couple of options in regards to that. Okay. If you want to turn it in person, turn it in person. If you want to turn it in online, that's fine too. Okay. Just wanted to give you a heads up on that. Again, it's not due until next Wednesday. Again, that doesn't mean you got to wait till next Wednesday. But the class assignment is right there. Click on it. You can see it, hit print, and you're done. Okay. If you want to just work everything on your own paper, that's fine too. All right. I'm not real picky about it. Okay. So today, y'all, is the 14th. So we're about halfway through the month of September. Today, y'all, what we're going to do is we're going to go over section 3.2. Okay. The homework for 3.2 is due by next Wednesday. Y'all, just a friendly reminder, since last week was kind of a short week, last week we did 2.3 and we had the quiz. Both of those are due by this evening, okay? So if you haven't yet finished them, you still got some time, but just know that they're due by tonight, okay? So just wanted to let everybody know about that. Okay, so let's go ahead and go over section 3.2. Let me get my notes. They are right here. Okay, so 3.2, y'all, is talking about the addition of whole numbers. So I want you to notice what I have up here. We got a couple of sets. So it looks like the set A, capital A, has the letters A, B, C, and D, right? Because I got my set right here. I can look at it just like looking at the picture. And I can look at the set B, which has the letters E, F, and G, okay? So last week when we were here on Wednesday, we talked about the union of two sets, okay? So remember, the union of two sets just says, take everything in this circle, take everything in that circle, and throw them in one big circle, okay? So how many elements do we have here? We have 4, right? That's why it's saying the number of elements in A is 4. And here we have 3. And when we throw them all in together, we're going to have a total of 7, right? And so that's how we kind of talk about, adding whole numbers together, right? Okay, so y'all, that works as long as the two sets are what we call disjoint. What we mean by disjoint is they didn't have any letters in common. If you looked at the set A, it was just A, B, C, and D. And if you looked at the set B, it was just E, F, and G. But there was no little blocks with a letter that happened to be in both. When we have two disjoint sets, we can say that the number of elements in A and B is just going to be the number of elements in A plus the number of elements in B, okay? Now, if there happens to be an overlap, what I mean by an overlap is if there happens to be letters that belong to both, we're going to take the ones in A, we're going to take the ones in B, and we're going to subtract the ones that they have in both, okay? So the first problem here says, for which of the following is it true that the number of elements in A plus the number of elements in B is equal to the number of elements in A union B, okay? So first off, we know that our set A is the letters A and B, and we know that the letters, or the set B are the letters D and E. So what I want to do for part A, I want to figure out what does the set A union B going to look like. So remember what A union B looks like. It just says take everything in A, take everything in B, and throw them in one big set. So do you guys agree that A union B would be A, B, D, and E? Would that make sense, right? Because we're just throwing them all together. Okay, so look, if we're going to find the number of elements in A, how many letters did we have there? 2. Okay. And we're going to find the number of elements in B. How many letters did we have there? 2 as well, right? And then we're going to say, what's the number of letters that we have in A union B? How many letters do we have there? 4, okay? And so the question is it true that if we add those numbers, we get that number there? And we would say yes. So for the first part here, you guys, we're going to say that's true, okay? Now, I'm going to go through the same process, y'all, for parts B and C, okay? So look, let me go ahead and clean up some of this mess here. And let's do the same thing for parts B and C. Okay, so I'm looking at part B of the second one, and it's telling me that A are the letters A, B, and C, and B are the letters B, D, and F. Okay, first thing I want to do, y'all, I want to figure out what does the set A union B look like. Remember what A union B means. A union B means we're going to take everything in A, we're going to take everything in B, we're going to throw them all in one big set. Can anybody tell me how would I write A union B? What letters would I put in there? A, B, C, anything else? D and F, right? Do y'all agree that we don't have to list B twice because it's already there? Okay, so now what we're going to do is we're going to come back and we're looking at this piece right here, okay? So if I were to say, what's the number of elements in A? Everybody agree that would be 3? And if we said, what's the number of elements in B? Everybody agree that's also 3? And then now if we said, what's the number of elements in A union B? And we were to come back over here and we would look at, sorry, here's A union B. That would be 5, right? And so the question would be, if we add those numbers together, do we get that one? No, we don't, right? Guys, the reason why we don't is because there's some overlap, right? The little letter B happened to be in both of them, okay? So it's only going to be true if they don't have any overlap. So for this one here, y'all, we're going to say, you know what? That's false. It's not going to be true, okay? All right, I'm going to do the same process, y'all, for part C. Okay, so I'm just going to kind of scroll up here just so that I have a little bit of room, and I don't have much, but I'm going to try to do what I can. Okay, so let's look at part C. Okay, first thing I want to do, y'all, I want to know what does A union B look like. Okay, A union B means we're going to take everybody here and everybody here and throw them in together. So the set A has just a letter A. It's only one letter there. Now, we talked a little bit about this before, but the letter, or the set B, I'm sorry, is what we call the empty set. The empty set means there's nothing in there, okay? So if we take the letter A and we add nothing to it, does everybody agree we're still going to get the little letter A, right? Because there's nothing in the set B. Okay, so now let's go ahead and do that same process. Let's see if we can find the number of elements in A. How many letters did we say were here? Just 1, right? Okay, very good. And let's do the same thing for part B. How many letters are there if it's the empty set? 0, right? We have nothing in there. Very good. And so now if we were to say, what's the number of elements in A union B? We would say that's 1. And so again, the question would say, is this number plus that number equal to that number there? And we would say, yeah, that's true, right? Okay. All right, very good. Very good. So again, we're just kind of going through this idea. And the point here, y'all, is when we're doing these problems, we can go ahead and add the numbers in each set to get the number of the set in the union, as long as there's no overlap, okay? But if there is an overlap, then it's not really going to work. Okay, so now the second part here says, if we know that the number of elements in A is 25, and we know that the number of elements in B is 16, and we know that the number of elements in the intersection, again, the intersection, y'all, just means that they have 13 letters in common, or 13 elements in common, whether they're letters or numbers or whatever it happens to be. There's 13 of them in common. What would we know about the number of elements in the union? So what I'm going to do here, y'all, I'm going to use this little formula right here, okay? And I'm going to just write that down right here. So I'm going to say, look, the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements that they have in common, okay? So I'm using that little formula to see if I can figure out this part, okay? So let's see if we can figure this thing out. So we're looking for the number of elements in the union. Now, we already know that the number of elements in A, y'all, was 25, okay? And they told us that the number of elements in B was 16. And they also said that those two sets had 13 letters or elements or whatever you want to call them in common. So we're going to subtract that number, okay? Okay, so, y'all, I'm just going to kind of do it this way because I think this probably makes it a little bit easier. What's 16 minus 13? 3. And so 25 plus 3 is going to give us a total of 28, right? Okay, so again, just kind of using that formula to kind of figure out how many elements do I have in either the union or each of the individual sets, all right? So I'm going to kind of keep scrolling along here, y'all. And let's take a look at this next one. And it says, look, let the number of elements in B be 3, and let the number of elements in the union be 9. And part A says, what are the possible values of the number of elements in A? Okay, so I want to think about this for a second. Okay, the number of elements in B is equal to 3. Does everybody agree that that means that B is going to have like 3 letters or 3 numbers or something like that, right? So maybe we could say, look, how about if the set B has those right there, okay? Now, we also know that the number of elements, when we put them all together, is equal to 9, okay? It's equal to 9. So if the number of elements that they have together is equal to 9, how many would A have to have? So we already know that this one has 3. How much do we have to add to 3 to get to 9? 6. Okay, so let me ask you a question. Just to make sure, and I know I'm using numbers here, but I'm using numbers because I want to just make sure I understand that there's a subtle difference here. Okay, so look, here's my set A. I'm calling it the set of the numbers 1 through 6. Okay, first question, does everybody agree that they don't have anything in common because one of them are A, B's, and C's, and the other one is 1 through 6? And so we were to add them together, wouldn't we get 9? Okay, so first question for part A, it's possible that A could have 6 elements in there, right? Question, if we did this, let me do this real quick. Okay. And let me use a different color. I don't know, I'll go back to red. And I added the letter A in there, okay? And I said, look, if we wanted to put these letters together and these letters together, would we count the letter A twice, or would we still count it one time? We'd still count it one time, right? So my question to you is, if I took all these people here and all these folks and we said, what's the number of elements in the union, would it still be equal to 9? What do you think? So remember, we're not going to count the letter A twice, right? We're only going to count it once. So aren't those 3 right there? And aren't these 6 here? Isn't that still going to give me 9? Does that make sense? Now, the question I want to ask you, though, how many elements do I have here, though? Okay, so the number of elements in A could really be 7 also, right? Okay, I'm going to keep playing this game, y'all. So look, I'm going to do this. I'm going to add B to that set, okay? And if I add these 2 sets together, right? Remember, I'm not going to count the letter A twice, and I'm not going to count the letter B twice. So my A union B would still look like this, A, B, C, and then 1, 2, 3, 4, 5, and 6, right? My union would still look like that. Are there still 9 letters or 9 elements here? Yeah. But how many letters or elements do we have a total of now in A? We have 8. Okay, y'all, I'm going to play this one more time. What do you think I'm going to add to it? We're going to add C to it, right? And so now when I do this again, my union stays the same, right? Because I'm not adding anything additional, but now the number of elements in A is going to be equal to 9. So for part A, I actually have 4 answers. It could be 6 elements, it could be 7 elements, it could be 8 elements, it could be 9 elements. Now, y'all, if we added something additional, something that was not there, right? So let me use green. Suppose we did D here, right? And we did this. Wouldn't I now have to add D to that set? And so now the number of elements in the union is no longer 9, but it would actually be 10. So that's why I can't, that's why, oops, let me get my eraser. That's why I can't do this part here, okay? So it's going to be 6, 7, 8, and 9. Okay. Now, to do part B, we've actually already answered part B. Part B says if the number of elements in A and B, if the number of elements that they have in common is 0, meaning they don't have any letters in common, what are the possible values of A? So y'all, we did this actually. When we were going through our process here and we had this, do y'all agree that that set and that set don't have anything in common? So how many letters did we have here? 6, right? So we would say for part B, the number would have been just 6, okay? When they didn't have any overlap, when they didn't have anything in common, it was just really going to be 6. But because the set B has 3 elements, we can add each of those elements to the set A, and the union is not going to be any different, okay? All right. So y'all, going to the next part here, we have a theorem, and this theorem is called the closure property of addition of whole numbers. And the closure property basically says if A and B are whole numbers, then A plus B is a unique whole number, okay? What we mean by closure is, I think the easiest way to do it is just kind of explain the first problem here, this little piece right here, and I'll kind of go through that process. Okay, so we're talking about the closure property of addition. So what I want to do is I want to make every possible combination of adding of the numbers that I have in that set, and let's see if all the answers are still in this set here. So look, y'all, we have really 2 numbers. We have 0 and 1. So I'm going to make every possible combination that I can make. So 0 plus 0, 0 plus 1, 1 plus 1. Guys, I'm not doing 1 plus 0 because we know that when you add, it doesn't really matter which number comes first and what number comes second. Okay, so first question, what's 0 plus 0? 0, okay. What's 0 plus 1? 1. What's 1 plus 1? 2. Okay, the way we know if a set is closed under addition is that all the possible answers we get are also in that set. But right now, one of those numbers is not in that set, right? Which one is not in the set? 2. So we would say it is not closed under addition. Okay. And in order for it to be closed, all the possible combinations have to be in that set there. Okay. So look, y'all, I'm going to do the same thing for part B. So here's the set B, or part B is the set T, which are 0, 6, 12, 18, 24. Y'all know what the little dots mean, right? It keeps going on forever. Now, question, y'all, all those numbers there are multiples of what? They're all multiples of 6. So what we want to ask ourselves is if we add 2 multiples of 6 together, would we still get a multiple of 6? Okay, so look, let's take any 2. Okay, let's take any 2 numbers. Say 6 and 24. If I were to take 6 and 24 and I were to add them together, what number would we get? 30. Is that also a multiple of 6? Yeah, it's right there, right? Okay, look, let's try 18 and 24. 18 and 24 should be something like 42. Is 42 also a multiple of 6? Yeah. Okay, and so let's try something a little harder. I'll tell you what. Let's add those numbers together, right? Because every possible combination, those numbers we know are going to be in that set. Let's add those. 30 and 42 is 72. Is that a multiple of 6? So y'all, and I'll actually put a link for this in our Blackboard page so you can see it. But I use this, I'm trying to see if I can find it. Here we go. I use this in my Math 100 class. And so I'll provide a link for y'all for this. And it's just a, blank multiplication table, but it's a 20 by 20 table. So it's, it's pretty big, right? And let me do this, and let's go highlight. And let's take a look at our 6s. And hey, look, there's my number 72, right? So y'all, question, do you think if we keep playing this game here, let's see, here we go. If we keep playing this game, do you think we're going to keep getting multiples of 6? It looks like it is, right? So for part B, we would say this one is closed, right? It is closed, meaning that every single possible combination we do is going to give us another number that happens to be in that set, okay? All right. Now I'm going to do part C here. Part C is the set F, which looks like it starts with 6, 7, 8, 9, 10, 11, and so on and so forth. Okay. So again, remember y'all, what we're doing here is we're adding every possible combination that we can of those numbers in that set. And we want to know, hey, is every one of those answers we get, is it still going to be a number that's here? Okay. So if we were to add, again, I'm just kind of going through examples here. If I were to add, say, 6 and 11, right? And again, I'm just picking numbers at random. What number would we end up with? 17, right? Do y'all think 17 is going to be in this set? Yeah, because it keeps going on and on and on forever, right? That's what the little dots mean, right? It's 6, 7, 8, 9, 10, 11, and we're never going to stop, okay? So let's see. Let's pick another 2 numbers. Guys, let's pick 6 and 6. Let's pick some small numbers there. Those are the smallest numbers that I got in my set. I can't pick anything smaller than that. 6 and 6 is going to give us what? 12? Isn't that going to be the number that's going to be right there? Now, question, do you think for every pair of numbers we add up, it's going to be another number further down the line? Yeah. So again, this one here is also going to be closed. Okay. Okay. So we got one last part to do here for this problem here, part D. And it says the set that we're dealing with, y'all, the way they write it is like this. Okay, so what this means is we're looking at elements of the set W. The set W, you guys, are whole numbers. Just to give us an example of what whole numbers look like, whole numbers start with 0, and then they just go on forever and ever and ever, okay? And they never stop. Now, we're not just looking at whole numbers, we're looking at whole numbers that are bigger than 92. Does anybody know what's the first number that's bigger than 92? 93. Okay, so look, y'all, what I would do is I would say, look, these are really the numbers that I'm looking at, okay? Now, one thing I want to mention here, y'all, the way I'm going to do this problem is essentially the same way we did part C. And I'm going to look at those possible combinations that we could add. And the only difference between part C and part D is in part C, we started at 6, but in part D, we're starting at 93. But the idea is going to be the same, okay? So again, if I were to say, let me take any 2 numbers in here, 93 and 94, that would give me 187, right? Do y'all agree that somewhere way down over here, the number 187 would be in there? Right? And isn't it going to be the same sort of process? Because if it worked for 6, 7, 8, 9, and so on and so forth, it's going to work for 93, 94, 95, and so on and so forth. Yeah. So we're also going to say that this one here, y'all, is also closed. So again, in order for it to be closed, you're going to look at all the possible combinations, okay? And when we look at all those possible combinations, when we add, because we're talking about under addition, right? We're not talking about multiplying, we're not talking about subtracting or dividing, we're talking about adding. We want to make sure that all the numbers are going to be in that set, okay? And that's why in the first one we did right here, it was not closed because when we took 1 plus 1, that gave us 2, and that was not a number in our set. Okay, so I'm going to scroll on here. And I'm going to do the same sort of process here, y'all, for this next part. So this next part here says set A is closed under addition. So they're already telling me it's closed, okay? And set A has the numbers 4, 7, and 11. We want to list 6 other elements that must be in the set A, okay? So the process and how I'm going to do this, y'all, I'm going to go like this. A is going to be, so far we know we have 4, we know we have 7, and we know we have 11. And there's other numbers in there. They might be here, they might be over there, but there's other numbers. What we want to do, we want to find 6 of those other numbers. So remember what we said we're going to do. We're going to take every possible combination. So could we take 4 plus 4? And if we were to add those numbers, what would we get? 8. Okay, so that number is going to be in there. Okay. Could we take 7 plus 7? That's 14, right? Okay, we could also take 8 plus 8, that's 16, right? We could take 4 plus 8, and that would give me 12, right? Again, I'm just looking at different possible combinations here, y'all. Could we take 7 and 8? And I'm getting 15. Now, I'm looking at the numbers that I'm coming up with here, right? Now, I'm not necessarily saying that I'm done yet, but I'm at least looking at the numbers that I'm coming up with, okay? So far, y'all, in my answer, I have 8, 14, 16, 12, and 15. Now, when I start looking at my answer choices here, right, we got 4 choices to choose from. Just based on what we have, what answer makes the most sense? A, B, C, or D? Anybody know? So let me phrase it this way. If I look at choice A, is the number 1 coming up here at all? No. Okay. Well, if the number 1 isn't coming up here, isn't that going to eliminate those? So look at the numbers that we're coming up with. We're coming up with 15, 22, 28, 32, 36, and 40. Well, look, we already had 15 here. If I wanted to come up with 22, couldn't we take 11 plus another 11? Hey, there's my 22, right? If we wanted to come up with 28, couldn't we take 16 and 12? And there's my 28, right? So I can kind of see that, look, these aren't, remember, it's just saying list 6 other elements. It doesn't necessarily say that, hey, well, I need to make sure that I have the 8 there, the 14. It's just saying which one is going to be my best choice. So D here, y'all, is going to be my best choice, right? And again, I'm just using the process of elimination, right? Okay, we're going to do the same process here. It says set A contains the element 2. What other whole numbers must be in the set A in order for it to be closed under addition? Okay, so let's think about that for a second. So far, I know that my set A has the number 2. And I want to know what other numbers got to be in there. So remember, when we're doing closed sets under addition, we're going to take every possible combination. Well, let's start off with 2 plus 2 because we know that's going to be a number. So 2 plus 2 is going to give me 4. Okay, so I'm going to put a 4 right here. Okay, guys, could we do 2 plus 4 and give me 6? And that's going to be that number there. And can I take 2 plus 6 and that's going to give me what? 8. And can I keep playing this game forever and ever and ever? Okay, so now what I want to do is I want to look at my answer choices that I have here, okay? And I want to see which one of those best fits my choice. So look what it says here, only the numbers 0, 2, 4, 6, and 8. Now that doesn't make sense because I already know we had what number? We already had 10, right? So I know that's not going to work. Okay, the rest of the whole numbers. Y'all remember what the whole numbers look like? Whole numbers look like this. Okay, are all the numbers that I have here also here? No, because I don't have the ones, I don't have the threes, I don't have zero. Okay, so I know that's not going to work. Okay, the rest of the whole even, the rest of the even whole numbers greater than 2. Does that look what that describes? Right? Yeah, so I'm going to pick C, only in the number 0. That was not even a choice, right? So yeah, we're going to pick part C, the rest of the whole even numbers greater than 2, right? And again, I'm just kind of working my way through the process so that I can kind of have an understanding of what it is I'm doing here, okay? All right, good deal. So let me keep scrolling along here. Guys, at any point in time, if y'all have any questions, please, 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 please let me know. Okay, so the next part I have here, y'all, is something called the commutative property of addition. The commutative property of addition, the easiest way to explain this or to understand it, let me get my pen going, is commutative property says you can reverse the order, okay? What I mean by that, 2 plus 3, oops, that's a pretty ugly looking 3. 2 plus 3, isn't that the same thing as 3 plus 2? When we're adding, which one you put first, which one you put second, makes no difference at all, okay? That's the easiest way to talk about commutative property. Now, the associative property. The associative property says, y'all, that if I'm adding 3 numbers together, okay, and again, no matter how fast I add, I always add my numbers 2 at a time, okay? No matter how fast we add, we always add our numbers 2 at a time. The associative property says, what numbers do you add first? Do you want to go with the first 2 and then add the last number, or do you want to go with the second 2 and then add the number that you had previously? Okay, so I'm actually going to skip this problem, y'all. And they had a problem similar to this in the homework, but it's a little bit messy and sometimes the answers can be a little vague. So I kind of skipped over this one, but I'm going to do the next one, okay? So I'm going to kind of zoom out a little bit. Okay, and what I'm going to do is I'm actually going to write those properties one more time just so I don't have to keep going back and forth. So the commutative property says A plus B is equal to B plus A. The associative property says A plus B plus C is equal to A plus B plus C, okay? And so we're going to do this part here, and it says supply reasons for each of the first 3 steps given below. Okay, so y'all, one thing I want to mention is the associative property refers to how you group your numbers. Are your parentheses on the same numbers that they were before? The commutative property just says you reversed 2 numbers. You put the first number second and the second number first, okay? So first thing I'm going to do, I'm going to look at this line here, and I'm going to look at this line here. And the first thing I noticed was in the first part, we were grouping the first 2 numbers together. And on this piece, we're grouping the second 2 numbers together. This is grouping the first part. This is grouping the second part. So this is going to be the associative property of addition, okay? Y'all, by the way, when you're doing this in MyLab, it's going to be a little drop-down menu. So it'll ask you, is it the commutative? Is it the associative? Is it the closure property? Is it place value? It'll give you a whole bunch of choices, right? In this case, it's the associative property. Okay, when I look at the next line, I want you to notice that my parentheses have not changed. So because my parentheses have not changed, it cannot be associative. But what we did is we reversed those 2 numbers. So when we reverse our numbers, that's going to be, oops, the commutative property of addition again, okay? Now we're only doing this for the first 3 steps, okay? So we got one more to do. Now, I'm going to come back over here. I'm going to look at the next line, okay? Y'all, what I notice about the next line, my parentheses used to be on the second two, and now they're on the first two. So they used to be on the second two, now they're on the first two, so we're going back to the associative property, okay? And again, the associative property, y'all, just really refers to how do you group your numbers, okay? How do you group your numbers? And it's stuff that we do on a daily basis, or at least regularly, maybe not every single day. I don't know if you're adding numbers every single day, but you do it and you don't really think twice about it. And just to give you an idea, y'all, on how we used this earlier, I'm gonna scroll back up here real quick. And let me see if I can find it. Here we go. So earlier today, when we did, let me get my pen going here. Okay, earlier today, y'all, when we did this problem right here, and we said, look, the number of elements in A was 25, the number in B was 16, the number they had in common was 13. Instead of me adding those together and subtracting 13, I opted to say, what's 16 minus 13? Why? Because to me, that was easier for me to do. I knew it was 3. And then 25 and 3 is going to give me 28, right? Could I have added 25 and 16? Yes, we could. That would have given us 41. And 41 minus 13 would have still given me 28. But it was easier mentally to compute this part, right? So again, we still use those properties, okay? We still use those properties. All right, so let me keep scrolling along here. Okay, so the next part here, guys, in 3.2 is something called partial sums, okay? Partial sums says Hector computed his addition problems by placing the partial sums as shown. And it says use this method to work the accompanying addition problems. Okay, so the idea behind partial sums, y'all, says, look, if we were to add 8 and 7, what number would we get? 15, right? So look how he's writing the 15. He's just writing it right there underneath, okay? Now, if we were to add 6 and 4, what numbers would we get? 10, okay? So he's putting the 10 right here. And then if we were to add 6 and 7, we would get 13. We'd put it right there. And then all we're going to do, y'all, is just add down. 5, 1 and 0 is 1, 1 and 3 is 4. Bring down the 1, and our answer is 1,415. Okay, so we're going to do the same process here, you guys. We're going to determine the partial sums and work the provided problem, okay? So look, let's do it the same way we're doing before. I'm going to add straight down. What's 6 and 7 when we add straight down? Anyone know? 13. Okay, so look, y'all, I'm going to write my 13 like that, okay? Now, I'm going to do the same thing here. I'm going to add these numbers. What's 7 plus 4? Okay, so we're going to put a 1 here and the 1 right there. Okay, and then we're going to do this a third time. What's 9 and 3? 12, right? Okay, now again, y'all, all we're going to do is add straight down. That's 3, that's 2, that's 3, and that's 1. And that's the idea of partial sums, okay? All right, let's try the same thing for this next problem here. Okay, and so again, I'm just going to add straight down. Anybody knows 6 and 8? 14. So look, there's my 14. Okay, what about 2 and 6? It's just 8. So I'll leave my 8 right there, and then we're just going to bring down the 5. Okay, so if we were to add down, that's going to give me 4, 9, and 5, right? 494. Okay, so y'all, just to give you an idea, because again, you know, we learned how to add and we learned how to carry, all that kind of stuff back in grade school. But I want to show you an idea here. Let me see if I can find it. Where's my lab? Here we go. Here's my lab. So what I'm going to do here, you guys, I'm actually going to do a problem that's directly in the homework. So let me click on my homework real quick. Okay, here's assignments. Okay, so here's 3.2. So 3.2 is already open right now. I don't know what question it is. I'm going to look for it real quick. Okay, we did a problem like that already. We did a problem like, oh, this is like the one we did right now. So you see what I'm saying? It's going to be associative or commutative, okay? And I think this is, here we go. Okay, so look, just to kind of give you an idea, look, if I was doing this problem here, And I'm going to see if I can zoom in a little bit. There we go. That probably looks a lot better. What's 7 and 6 going to give me? 13. So look, I'm going to write 13 right there. Okay. What's 9 and 6 going to give me? 15. Okay. And what's 8 and 2 going to give me? 10, right? And then, so when we add this out, I know I'm going to have a 3 on that side. 1 and 5 is going to give me a 6. A 1 and another 1. So 1163. That seemed like I made sense, right? Okay, and let me see. Let me zoom back out. And let's check our answer. And we got it, right? So just to give you a heads up, that's how they're asking you to do it on MyLab, right? But guys, before I go on, didn't we do this problem the same way we did it on paper, right? It's just, I'm just kind of showing you that they're not asking you just to give the final answer. They actually need to kind of go through the process, right? So look, let's do the next one because, you know, it's got to be easy breezy, CoverGirl, right? So let me zoom in here real quick. And let's see if we can't figure it out. So we're going to add straight down. What's 4 and 8? 12, okay. What's 6 and 2? 8. And bring down the 3? Okay, so if I start adding, I know on the left-hand side, I'm going to have a 2, okay. 1 and 8 is going to give me, oops, a 9. And bring down the 3, and let me zoom back out. And let me go chickadee check, and we got it, right? So again, just kind of wanted to show you the process on how they're asking you to do it on MyLab, right? But it's very similar to what we just did, okay? So let's come back over here, and let's see what else we got. Okay, so guys, the math in this class shouldn't be like extraordinarily hard. At least I'm hoping it's not. It's just more of like the idea on how do you talk to kids about this, right? And to be perfectly honest with you guys, I've never taught elementary school. I've never taught junior high or high school. I did like a substitute teacher, I don't know, a long time ago for junior high kids. But I mean, what do you do as a sub, right? You go in there and say, hey, just, you know, act right? Act right for the next hour, and you know, whatever y'all need, I'm going to help you as much as I can. But you know, if I'm substituting, like say a social studies class, what do I know about social studies, right? I'm a math guy. But there's something called the opposite change algorithm, okay? And it says in the opposite change algorithm for addition, we decide which addend is closer to a nice number, typically like a 10 or a multiple of 10, and then decide how to adjust that addend so that it ends in one or more zeros. And then adjust the other addend the opposite way. What they're talking about addend, y'all, is the first number and the second number, right? It says the goal is to make the addition problem a problem without the need to regroup. Okay, it says, for example, if we were going to add 189 to 278, okay, the first thing we would do is we said, look, how much are we going to add to 189 to make it end in a 0? We're going to add 1 to it, right? So we get the number 190. Well, if we're adding 1 here, we got to do the opposite. We got to subtract 1 from over here, because if we want to add the numbers together and get the same answer, if you add something to one side, you got to take away from the other piece, right? So from 278, we went to 277, okay? And then they said, look, from 190, let's make it an even prettier number by rounding that to the, like by going to say 200. So how much did we have to add to get to 200? We had to add 10. Well, if we added 10 here, we got to subtract 10 from here. And the idea is, if you're dealing with younger children and you want to get them to add these two numbers together, ideally it should be easier if you're adding 200 and 267, because you know that 0 and 7 is going to be 0, 0 and 6 is still going to be 6, and then just add the 2's. Does that make sense? Okay, so we're going to do the same thing here. It says use the opposite change algorithm to compute 279 to 452. Okay, so look, 279 and 452. Okay, you know, if I wanted to get this to say a really nice, pretty number, like say 280, what number am I adding? We're adding 1, right? So if we add 1 here, then we got to subtract 1 from here. Wouldn't that be 451? Okay. Now, again, I'm trying to make this as pretty as possible. So if I want to take 280 and I want to say round it to a really pretty number like 300, what number am I adding here to get to 300? We're adding 20, so we're going to subtract 20. So what's 451 if you take away 20? What, 431? Now, if we were to add those numbers together, that would give me a 1, that would give me a 3, that would give me a 7, and we didn't have to do any kind of carrying over. Do you understand the point? Okay, so we know the answer is going to be 731, right? So there's our answer, 731, and you might say, sir, if I were just to add those two numbers together in my calculator, wouldn't I still get 731? Of course you would, right? But the question says, what friendly numbers should first be added or subtracted to 279 to make an even 10 or an even 100? What was the first number we added or subtracted? 1. So this question, y'all, is going to kind of come in two pieces. So the first part you would say, well, we added or subtracted 1, right? And then when we did that and we went through the process, we came up with 731, right? But the idea is just how much are you having to add or subtract first? Okay. All righty. So the next problem I have here, y'all, says perform the operation using the indicated base. Okay, so I want you to notice something here, y'all. We're dealing in base 6. Okay, we're dealing in base 6. So just to give everybody a reminder of what does base 6 look like, the numbers that we have, y'all, are the numbers 0, 1, 2, 3, 4, and 5. We never go past 5. Okay, we never go past 5. So what I'm going to do here is I'm going to add my numbers together. Okay, and I'm dealing in base 6. Okay, so we're going to add straight down. 5 and 2. Does everybody agree 5 and 2 is going to give me how much? 7, right? But we're dealing in base 6. So what I want you to think about is how many 6s are in the number 7? In the sense of, like, if you were to take 7 and you were to divide it by 6, how many times would it go in nice and pretty? 1 time, right? That would be 6 with a remainder of 1. So this 1 right here, you guys, is going to go right there. And that remainder is going to go right there. What this means is that there's 1 6 and 1 1. Okay. Oh, sorry. I put the 1 in the wrong spot. 1's got to go up here. Sorry about that. Okay. Now we can add these numbers together. What's 1, 1, and 1? 3. So there's my answer, 31 base 6. So when we're adding in the particular base, whether it's base 6 or base 7 or base 2 or base 5, the first thing that helps me, y'all, is to write down what kind of numbers should I be getting, or what kind of numbers am I working with. I'm only working with 0 through 5. If I'm in base 6, the smallest or the biggest number I'm going to have is going to be 1 less than my base. Okay. All right, I'm going to kind of keep moving along here. And we're going to start talking a little bit about rounding, you guys. And there's going to be some processes in rounding here dealing with 3.2. Okay, so again, when I teach, like, say, Math 100, and I don't know if anybody here took Math 100, but Math 100 is basically a class when you finish high school and you come to college, if you're not really ready for the college level math yet, you take Math 100. But even, y'all, when I teach other classes, the idea of rounding just means, is this number closer to this number or is it closer to that number? It doesn't mean it's equal to it. It just means which one is it closer to. So what we do here, y'all, in rounding, we're going to round to the nearest 100. So when I have 6,387, the hundreds that I'm thinking of are 6,300 and 6,400. Okay, either what the digit is or possibly one more. And the idea here, y'all, is 6,000. Sorry about all that mess, y'all. Okay, so the idea here is the number 6,387. Is it closer to 6,300 or is it closer to 6,400? Yeah, it's closer to 6,400, isn't it? And that's the idea. When it says round, we're just trying to figure out, is it closer to one number or is it closer to another? So y'all, I'm recording the lecture because for my online class, I posted to their plate with the same YouTube playlist if you guys want to watch it. So those of you who are online, in our classroom right next door, they're doing some construction or something and it's a little messy and noisy, so I apologize. I hope it's not too bad. Okay, so the next few problems, y'all, are dealing with estimation. Estimating is, again, really similar to the idea of rounding, okay? And there's a couple of different approaches on estimating. The first one is called front end with adjustment. And so the process, y'all, when we're going to do front end with adjustment, the way we're going to do this is we're going to add the digits in the thousands place value, and then we're going to round the numbers in the hundreds position to the nearest hundred, and then we'll add those. Okay, so let me show you what I mean by this. First thing says add the digits in the thousands place. So we're going to add those numbers together. 2 and 3, everybody agree that's going to give us 5,000, right? Okay, now what we're going to do is we're going to round the other numbers to the nearest, around the rest of the numbers to the nearest hundred. So 225, would that be closer to 200 or 300? What do you guys think? Anybody know? Closer to 200 or 300? Yeah, it's going to be closer to 200, right? Okay, so that's going to be 200. Now, y'all, I'm going to look at this part of the number. 218, is that closer to 200 or 300? 200 again, okay? Now, I'm going to look at 46. Is that number closer to 100 or is it closer to 0? It's actually closer to 0, right? Because I'm rounding to the nearest 100. And then 463, is that number closer to 400 or 500? 500, okay. So now we're going to add these numbers together. So let's see. 200 and 200 is 400, and 0 is still 400, and 500 is 900. So my answer here, y'all, should be 5,900. Okay, should be 5,900. Again, this is the idea of front end with adjustment. Add the numbers in the thousands and then round each other number in the hundreds position. Okay, look, let's try the same thing here. So we're first going to add the digits in the thousands position. So 2 and 1 is 3, and another 2 is 5, and another 2 is 7, and one more is, okay, 8,000. All we did is add the numbers in the thousands position. Okay, y'all, what we're going to do now is we're going to round each number to the nearest 100. 350, closer to 300 or 400? 400, right? Okay, great. 967, is that closer to 900 or is that closer to 1,000? 1,000, right? Great. 52, is that number closer to 100 or closer to 0? Closer to 100, right? Great. 109, closer to 100 or 200? 100, excellent. 894, closer to 800 or 900? 900, excellent. Man, I could have stayed home today. Y'all already know what to do. Let's add our numbers together. So look, we know those are going to be zeros. 9 and 1 is 10, and 11 and one more is 15. So I'm going to carry that one there, and 1 and 1 is 2. And so y'all, if we add 8,000 and 2,500, everyone agree we're going to end up with 10,500? Okay. So again, this is my process and how I'm going to do this with front end with adjustment, okay? Front end with adjustment says add up all the thousands and then round every number after that to the nearest 100. Now, the next one here says grouping to nice numbers, okay? What we mean by grouping to nice numbers is, this one here, y'all, I'm not a big fan of grouping to nice numbers because it says try and pair up numbers that add up nicely together, right? And sometimes it can be a little vague, like which ones should I pair up? So I want you to notice the reason why I'm pairing these up together is that 46 and 63, isn't that roughly about 100? I know it's a little bit more than 100, but it's kind of close to 100. So if I were to add 3,400 and 46, do you guys agree that I'd end up with something about 3,500 roughly? In the sense that that's 40 and that's 60. I know it's closer to 50, but those kind of give me something close to 100, another 100, so it's 3,500. And then if I were to add these together, I know that's a 2,000. 225 and 218 if I were to add 25 and 18, what's that going to give me? 343. Okay. So I would have something like roughly something like this. Now, would you say that that number is closer to 2,400 or 2,500? What do you, 2,400, right? And if we were to add those numbers together, 0, 0, 9, still coming up about 5,900, right? Now, y'all, I want you to notice the numbers that I'm dealing with are the same numbers that I had in the first part. So if my answer here is 5,900, my answer here should still be about 5,900. You know, I might be off a little bit because I'm using a different approach on rounding. But if my answer in the first part was 5,900, my answer in the second part should not be something like 11,000, right? It should still be something relatively close to 5,900, right? Okay. So again, I'm not a huge fan of the grouping to nice numbers because I think it can be a little tricky sometimes to figure out which ones are the nice ones, right? So like again, in this problem here, you guys, what I might do in terms of my nice numbers, I might kind of group these together, right? Because if I think about this, isn't this kind of close to 1,900? And isn't this close to 2,100? And if I were to add 2,100 and 1,900, how much would I end up with roughly? What, 4,000? Right? That would give me about 4,000, right? Okay, now y'all, if I were to group those numbers together, say 1967 and 2052, okay, if I were to kind of group those numbers together, 0 and 2 would give me 9, and 6 and 5, that give me an 11, and I would carry that one over, so that'd give me a 2. Wouldn't that give me something, again, roughly close to another, say, 4,000, right? And if I were to look at, say, this number right here, 2350. 2350, if I was going to round that, say, to the nearest 100, would that be closer to 2,300 or 2,400? 2,400, right? Okay, and if we were to add these numbers together, that'd give me a 0, a 4, 4 and 4 is 8, and 2 more is 10. So I'm coming up with about 10,400. Again, y'all, I want to point something out. These are the same numbers that I was working with before, right? Did we get, look what we came up with this time, 10,500? Look what we got this time, 10,400. We're still in that neighborhood, right? The idea is we shouldn't be, I'm rounding the same numbers, so I shouldn't have an answer that's vastly different from what I had before. Okay, now there's another process y'all called clustering. It says clustering is used when a group of numbers cluster around a common value. What they mean by that, y'all, is do these numbers roughly represent the same number, each one of those, or do they not? Are they all kind of pretty different? Yeah, they're different. That's 225, that's 2,200. These here cannot be clustered because in order for them to be clustered, they all have to be about the same number. They all have to be roughly the same value, okay? Now, y'all, when I look at this one here, and I'm still using the process of clustering, okay? If I were to think about rounding each of these numbers, say to the nearest 1,000, okay? If I was rounding to the nearest 1,000, so these are the numbers that I want to round. 2,350, would that number be closer to 2,000 or 3,000? 2,000, right? 1967, is that closer to 1,000 or 2,000? 2,000 again, right? 2,052, everyone agree closer to 2,000? Same thing with the 2109, closer to 2,000. And the 1894, again, closer to 2,000. So if we were to add those numbers together, 2, 4, 6, 8, 10, we're coming up with 10,000. That's what they mean by the idea of clustering. All of them should be roughly the same number. They should all be really close, and they're all really close to 2,000. I know it's not exact, but what we're doing here is we're estimating, right? We're estimating here. And so guys, you can see for this part here, we kind of have like a low estimate, right? 10,000. When we did it earlier, we got 10,400. When we did it up here, we got 10,500. So again, It's an estimate. An estimate means that you should be relatively close to what you have, okay? All right, so for the next part here, y'all, we're gonna talk about rounding. And it says rounding is a way of changing numbers so that they're easier to handle. Rounding enables us to find approximate answers to calculations as follows. So we're gonna round each number either to the nearest 100 or the nearest 1,000 or the nearest 10. So like for a number like 225, I would probably round it to, if I was gonna go, sorry, I'm trying to get my pen working. I would probably round it to the nearest 100. 225, closer to 200 or 300? 200, right? Okay, 2,218, closer to 200 or 300? I'm sorry, closer to 2,200 or 2,300? 2,200, right? Okay, 46, I'm gonna round down to the nearest 10, closer to 40 or 50? 50, right? And 3463, closer to 3,400 or 3,500? 3,500, right? Okay, so now I'm gonna add my numbers up. 0, that's gonna be a 5, that's gonna be a 9. And so here, y'all, I'm coming up with 5,950, right? Again, that's my estimate by doing our rounding here. Again, one thing I really want to mention, y'all, I'm going to scroll back this way, right? And look what we got this time. We got 5,900. And what we did over here, we got 5,900 again. So when I'm coming up with 5,950, I know that my answer seems pretty reasonable, right? Because I'm still estimating. I'm just using different methods, okay? So let's take a look at this one here. 2,350. What do you think? Closer to 2,300 or 2,400? 2,400. Excellent. 1967. Let's round that to the nearest 1,000. 1,000 or 2,000? 2,000, right? Again, y'all, the idea of rounding, we're trying to make the calculation easier. 2052. Closer to 2,000 or 2,100? 2,100, right? Because as long as we're 50 or more, we get to round it to the next number, right? Okay, 2,109, closer to 2,100 or 2,200? 21. And say 1894, closer to 1,800 or 1,900? 1,900, okay. All right, so again, let's see if we can go through the process here. So that's a 0 right there, that's a 0 right there. Let's see, 9 and 1 is 10, 11, and 4 more gives me 15. Okay, so look, I have a 1 here and another 1 there, that's 2, 4, 6, 8, 10, 10,500. Again, that's what we got the other times, right? So again, my process of estimating is going to be relatively similar, okay? Y'all, by the way, when you're doing those problems on MyLab, it's going to be a drop-down menu. So it's going to ask you, okay, and it'll give you like 4 or 5 choices, right? So once you get your choices, say for the first part, because it's going to ask you to go through this process using these different methods, you know that your answer for the next piece, using a different method, should still be relatively the same, right? Should be relatively close to what you got. Okay, so I'm going to continue going on here, and there's something called the range strategy. Okay, the range strategy, you guys, is a range is kind of like how, you know, if you ever go to the doctor, right, and you do lab work, and they say, okay, you know, today we're going to check your cholesterol. And in order for you to be okay, your cholesterol needs to be between, say, 100 and 200. That's what we call the range, right? So we're going to use something called a range strategy. And a range strategy, you guys, is going to be rounding to low numbers and rounding to high numbers. So let me show you the process and how I'm going to do this. When we round to the nearest 100, 174, the question is always, is my number 174, is that closer to what in terms of hundreds? Is it closer to, yeah, but the question is always, is it closer to 100 or is it closer to 200? Y'all agree? Okay, and I'm going to do the same thing for the number 641. When we round, we say, hey, is this number closer to 600 or is it closer to 700? Okay, now, y'all, the way we do the range strategy is we say, look, let's add the low estimates. What would 100 plus 600 add up to? Okay, that's the number that I'm going to write right there. 700, because the low estimate of 174 would be 100, and the low estimate of 641 would be 600, okay? And the way we're going to do the upper part is we're going to say, look, let's add these numbers together. What's 200 and 700 going to add up to? Anyone know? 2 and 7? 900, right? Very good. 900. Because the upper estimate of 174 is 200, and the upper estimate of 641 is 700. And so now what we're going to say is that the way we're going to estimate this is it's going to range anything between 600 and 900. Does that make sense? So again, when we're talking about rounding, we're talking about, in this case, we're talking about rounding in the nearest hundred because our place values, or the biggest number we have, is hundreds. Guys, if there were thousands, I would round to the nearest thousand, okay? So look, let's try the next one. I want to make sure that we're doing okay with these here. So the first thing I have is 480. So the low estimate would say keep it at 400, and the high estimate would say round it up to 500, right? And I'll do the same thing here, y'all, for the number 217. 217. The low rounding would be 200, and the higher rounding would be 300, okay? So again, the process is going to be the same here. We're going to take the low estimates and add them together. 400 plus 200 would give me 600, right? That's because the low estimate of 480 would be 400, and the low estimate of 217 would be 200, right? And then if we were going to do the upper estimates, right, we would take the bigger of the two numbers. 500 and 300 would give me 800, because the high estimate of 480 would be 500, and the high estimate of 217 would be 300. And so now we're going to say, look, this thing is going to range anywhere between 600 and what? And 800, right? And so that's how we kind of use the range idea, right? So if you guys are ever like in the market for like, oh, I want to buy a new refrigerator, you start looking, right? The range, what's the cheapest refrigerator? What's the most expensive, right? And then you kind of start narrowing that down. Well, you know, the most expensive refrigerator is like, I don't know, $7,200. I'm like, man, I don't got anything that needs to be that cold. So you start kind of whittling it down, right? All right, I think there is, yeah, I don't know why there's so much space here, but I think there is one last problem here, y'all, out of 3.2. And the biggest problem that we have here is George. So I'm going to read through the problem, y'all. George is cooking an elaborate meal. Guys, this problem is directly out of the homework, okay? So I didn't write this problem. He can only cook one thing at a time in his microwave oven. His turkey takes 90 minutes. Yes, that's what the problem says. Okay, I don't know about you guys, but I'm not going to George's house to eat, right? Okay, so his turkey takes 90 minutes. The pumpkin pie takes 13 minutes. Rolls take 60 seconds. George is going to give all of us stomach problems, right? And a cup of coffee takes 30 seconds to heat. How much time does he need to cook the meal? And then when does he need to start in order to complete the cooking at 4 o'clock? Okay, so let's do this. Besides the fact that George is going to get everybody sick, let's take our times, y'all, and let's see how much time he needs. Okay, so we know that he takes 90 minutes for the first thing, right? And the second thing is 13 minutes, right? Now, it says that he's going to make something in 60 seconds, but 60 seconds is really the same thing as how much? 1 minute, right? And then the last part is 30 seconds. So I'm going to write that over here on the side because I know that's going to be that. Okay, if we were to add these minutes together, 90 and 13 would be 103? 104? Everybody agree? 104 minutes and 30 seconds. But the question says we want to break this down in hours, minutes, and seconds. Okay, so if we have 104 minutes and we want to break that down into hours and minutes, does everybody agree we would have to take the number 104 and we would divide it by how many minutes in an hour? Yeah, we divide it by 60, right? So everybody agree it's going to go in one time? And we're going to end up with 44 minutes as our remainder? Okay, so do y'all agree that George needs 1 hour, 44 minutes, and how many seconds? And 30 seconds to cook the meal, right? Okay, so guys, there's a second part to the question because the first part says, how much time does it need to cook the meal? Hey, we figured that part out, right? The second part of the question says, when does he need to start cooking, or when does he need to start in order to complete the cooking at 4 o'clock? Okay, so let's think about it this way. He needs 1 hour, 44 minutes, and 30 seconds, okay? And he wants to be done by 4 p.m., okay? So, let's just do this in pieces. If it was going to take him an hour to do it, y'all agree he would have needed to start at 3 p.m.? Okay. And if it was going to take him 44 minutes, what time would he needed to start at? What's 44 minutes before 3 p.m.? Anybody know? 2 o'clock and what? So 4 p.m. Remember how many minutes? So wouldn't I say 60 because there's 60 minutes in an hour? Minus, not 40, I'm sorry, but 44? 16? Right? He would have needed to start at, oh, you know what? He also needs another what? 30 seconds? So if I'm going to start 30 seconds before this, so wouldn't he need to start at 2, 15, and what? 30 seconds, right? He would need to start at 2, 15, 30 on the dot in order to do everything. And yeah, I'm pretty disturbed about that problem, but right, don't go to George's house, guys. Right. Okay. So anyway, y'all, that is the end of 3.2. Again, so we'll talk about 3.3 starting on Monday. Y'all, just to give you a heads up, let me go ahead and come back to this over here, and I don't know if nobody's with us right now online, but that's okay. Y'all, and I want to mention this because this applies to everybody, whether you're in my in-person class, y'all, or whether we're in the online version, but I'm looking at the calendar that I have here. So y'all, right now we're in week 4. So we just did 3.1 and 3.2. Next week, we're going to continue 3.4 and 3.3 and 3.4, 3.5 and 4.1, and then in week 7. So in 3 weeks, y'all, we're going to be taking our first test, okay? In the next week or two, I'm going to set up a review for you guys for the test. The test is going to cover the first 3 chapters. So we've already got 1, 2, 3, 4, 5, 6, 7. We already got 7 sections, 8, 9, 10. We got a total of 10 sections, okay? So I've already made the review, guys. I think it has like 40-something questions. I'm still working on the test. But as we get closer to that time, I'll talk to you a little bit more about that. But I just wanted to give everybody a heads up that in a couple of weeks, we'll be getting ready for our first test, okay? But anyway, just wanted to tell you guys that stuff. So let me go ahead and stop recording.